How you doing, friends? Working here on Math 7's Weekly 7, number 31. Okay, look at question number 1. It says solve for x. We need to go ahead and distribute. So we're going to go ahead and say 5 times x. Well, 5 times x is just really 5x. And we need to pass it out to the 5 times a negative 2, which is going to get us a negative 10. And then we're going to just copy what we had was negative 30. So we want to make some zero pairs and we want to make some canceling. So in order to do this one, we're going to actually add in balanced sets. So I'm going to add in 10 to both sides. And by adding in 10 to both sides, it's essentially going to make this a zero pair. So that's gone. And I just have 5x over here. So I have 30 plus 10, which is 40. Okay, so we want to divide by 5, and we will get 40 divided by 5. Remember that fraction line means divide. So 40 divided by 5 really equals 8. Okay, we want to look at this one. To do volume, we need to do a base times height. So area of the base times the height. So we have 4. Some people call it length times width times height. That's fine too. So we have this side, this length is 4. And then we have this side is 5. And we have a height of 4. Okay, so we need to multiply that together. So this is pretty straightforward. We have 4 times 5, which is 20. And then we have 20 times 4, and that would give me 80. This one, we need to do the same thing so we can compare them. And we need to see that this side is a 4, this side is a 3, and then we have 1, 2, 3, 4, 5, 6 here. So we need to do the same thing and do some multiplication. So we have 4 times 3, which is 12. And then we need to do 12 times 6. Well, if we didn't know what 12 times 6 was off the top of our head, we could do traditional algorithm. Or I could look at it a little differently, and I could realize that I have really 10 times 6 and 2 times 6. I know that 10 times 6 is 60 and 2 times 6 is 12. So 60 and 12. And that's what I would do in my head. I just don't, normally you guys don't know that's happening, but I share with you what I do. Okay, so next we have the graph at the right, and it shows a proportional relationship. What is the rate? What is the unit rate? So we want to know per 1. How much does it move per 1? So we don't have 1 on here, so we can't just guess. So we need to figure out where does it hit one of these lattice points at, which is right there. And we know that we need to go up 20 and over 10. So if we go up 20 and over 10, up 20 over 10, really that just turned into a division problem, and it would tell us our unit rate would be 2, because 20 divided by 10 is 2. All right, next question. It says find the area and label it. They give us the area formula, which is area equals pi r squared. Well, the problem is they've given us the diameter. We don't want the diameter. We only want halfway across. So what is half of 8? Half of 8 is really 4. So we know that 4 is now our radius, which is what it's asking us for in the formula. So we have to do 4 times 4, because that's what squaring does, and that would give me my 16, and we're doing that times 3.14. So I look at that as 314 times 6, and, or sorry, 16, and that one's going to come out to 50.24. And we're going to say inches squared. Inches squared. If you need me to do the multiplication out for the 314 times 16, I could do that if you send me a note. I have question number 5. Question number 5 is a bit long because we see that when we're adding and subtracting fractions, common denominators are big, and we don't have a single common denominator. So we have 1/2, okay, plus 5/6. Well, the common denominator between the 2 and the 8 is 8. So it's 1/2. Well, half of 8 is really just 4/8. So now we can get this piece done. We would know this would come out to 9/8. Okay. So now we need to figure out what is our common denominator between an 8 and a 12. And, well, we want to look at our least common multiple, and the least common multiple would be 24. So, in order to get the equivalent fraction for 9/8 with a denominator of 24, we need to use the giant 1 and multiply times 3, which would give us 27 over 24. Same up here. We need to multiply both by 2. So what we're going to have here is we're going to have times 2. 7 times 2 is 14. And 12 times 2 is 24. But we have the opposite of a negative. The opposite of a negative is really just a positive. So here we go. We have 27 plus 14, which really gives me 41 over 24. And if we take a 24 out of 24 out, which is 1 whole, wow, that's not a very good one. 1 whole, then it would leave us with 17. So 1 and 17, 24. Sorry, I didn't have much room in that box. Next question over here is they give us the area, so we have to work backwards from the formula. So we have the base, okay, and then we know we have a half, and we don't know the height. So really what we need to do is work backwards. So multiplying by a half is really like dividing. So the opposite of division is multiplication. So we really want to take 120, multiply it times 2, because this is the original number we cut in half. So that would give us 240. And then we want to take 240 and divide it by whatever number we have left. Well, we have the base. This number does nothing for us. It is just the length of one of the sides. So we want to divide by 30. Well, I'm going to ignore my zeros for a second, and I realize I have 24 divided by 3, which is what? Well, 24 divided by 3 is 8. So our height is actually 8, and we're going to stick with what we have and say it's meters because it was meters squared. Last question, question number 7, says which dot plot shows, below shows 2 dot plots of 2 samples of different types of oranges and their weights. We have 1, 2, 3, 4, 5, 6, 7 below 10, and we have 3 above 11. Well, here's our 11 right here, and here's 3 already at 11. So we have 1, 2, 3, 4, 5. So it's almost always, but let's go with often. It's not always, because we have some that are down here below, which would fit on this side. So it's not always, but often. Thank you for watching. If you have any questions, email me, hit me up. See you. Hope everything's well.